Hi, my name is Dr. Chen, and I'm making a quick video on how to get started doing multi-level modeling. And part of doing multi-level modeling is to, first of all, get our data set into a type of format that works well for this type of analysis. Most times, whenever we see a data set in SPSS, it's a person level type of data set, as opposed to a person period type of data set, which is the format that we would need for conducting a multi-level analysis. Sometimes a person level data set is known as a wide data set, and a person period data set is known as a long data set. So kind of looks like this. And if you spend some time around some common statistical software like SPSS, you probably recognize something like the table above here, where each row represents the data from each person, and the columns represent the data points. So in this case, there's a subscale called strategy, and person with ID number 1 provided the following responses on week 1 for this subscale called strategy. This is the score on week 2 for the same subscale, and this is the score for week 3 in the same subscale. This is what the first row represents for one person across time points, and so on and so forth for the rows that follow after that. On the other hand, a long data set or a person period data set has something like this, where we no longer have multiple columns representing the same measure being administered at different time points. What we're doing is that we're kind of shifting this downwards, where each column now represents the different time points that a person is contributing data. So transforming this wide data set, a person level data set, into a long data set, or this person period data set, is going to look like this. Now we have person ID 1 having 3 columns representing week 1, 2, and 3. And these are the person's corresponding scores on the variable strategy on weeks 1, 2, and 3. And there's a couple of reasons why we do this. And one of the main reasons why we do this is because notice that we now have a time variable that explicitly models for time, specifically in this case, weeks 1, 2, and 3. And because of this, we're able to, number one, model this explicitly in our regression models, as well as be able to accommodate for different periods of measurements, different spacings between the measurements, and just overall do a better job of being able to model time in our regression models, specifically in our multi-level models. And so one of the first things that we need to do if you want to do multi-level modeling is to take something like this, because most I would say most survey programs tend to spit out a raw data set that is in a wide format. And we just need to transform this into a long data set. So this is what this video is all about. So I'm going to use R&R Studio as the applications to do this transformation. The R version that I'm using is 4.2.0, also known as Vigorous Calisthenics. And the R Studio version I'm using is 2021.09.0. Also known as Ghost Orchid. So just FYI, sometimes whenever these softwares update themselves, we may run into some issues, especially when it comes to more complicated analysis later on. If you're not familiar with R&R Studio, I would recommend looking up some other videos that may give you some sense on how to navigate the environment in R&R Studio. Plenty of awesome videos out there. I'm not going to spend too much time on this, but just to let you know what we typically have in R Studio. R Studio is basically a skin for R. And in R Studio, you've got a console on the far left, typically. And we've got the environment here that tells you what are the types of elements that you're creating with your syntax. And you've got some really nice point and click options here pertaining to different plots that you might make, different packages that you might want to download and run, and a nice help feature as well. In case you run into issues, you can always look for help. So first thing we need to do is to create an R Markdown document within our studio. I like R Markdown because it allows me to have my students actually submit a lot of their assignments in one document that contains your syntax as well as the output from the syntax. So I like to use R Studio for that reason. So let's go to new file. Notice that there's a bunch of different files that we can make. We're going to go with R Markdown. And this is the new file that we've created. I'm going to save this. I'm going to save this in the same folder as the folder where I have the data set that we're going to use for this demonstration. So that is going to be right here. It's important that we save this R Markdown file in the same folder where we have the actual data set, because that's usually the default way in which R Markdown tells R as to where the data set is actually at. I thought you can always set your working directory to do that as well. But usually it's just a lot simpler to just save the R Markdown file in the same folder as the data set. Okay, so let's add a chunk. Actually, hold on. I may have messed up. Close this out again, because this is not the RMD file. I must have picked the wrong option. Let's start over. If you're watching this in video, feel free to skip ahead to get to the right part of the video. The reason why it's doing this now is because I recently updated our studio to get the most up-to-date version of both applications. All right, this looks better. Convert. Put the output as Word. There you go. All right. Go ahead and just close all this. I'm going to save this, as I mentioned earlier, in the same folder. That's the same folder where I have the data set. Okay, so let's add a chunk. So within the world of R Markdown, we add a chunk to designate a space where we would actually type in the instructions or a syntax to the computer. And what this allows us to do is that it allows us to add headings, such as, say, import person level dataset. And then within this line over here, we would actually add in the instructions for letting R know, like, where what is the name of the data set and what function we should use to upload the data set into R. So I'm going to call this master dataset underscore PL for person level. You can call this anything that you want. It really doesn't matter. Read.csv is a function for reading CSV files. And there are a bunch of other types of functions that you can use to read SPSS files and so on and so forth. I like CSV because it tends to be the most simple and it doesn't have any hidden characters in there that may cause you problems in case when you upload and re-upload data sets. And the name is 6. So basically the instructions here is to read this CSV file. I'm going to call this master underscore PL. This should bring it into a global environment to start manipulating things with this data set. Okay, let's see. So I'm running into some issues here. I either got the name of the data set wrong, very possible, or I might just need to set up the directory. Okay, let's go ahead and do this. Chunk. Directory. Many times you could do this. Right click, get info if you're using a Mac. If it's a Windows, you click on properties. And this is the location. We are. See if you'll do that. All right, so you set the working directory. And there you go. It is a data set that has 40 observations with 44 variables. Let's take a closer look at it at this data set. So view is a function with capitalized V as the first alphabet in the instruction. So we can see here, this data set has 40 people with information on the semester in which the data set was collected, the gender, ethnicity, age category, and it has the basically these represent the sub-skill scores from week 1, 2, and 3 for each person. As you can see here, we've got the strategy sub-skill for week 1, strategy sub-skill for week 2, and strategy sub-skill for week 3, then non-acceptance sub-skill for week 1, non-acceptance sub-skill for week 2, and so on and so forth. This is actually from this data set here, just to give you a visual. Strategies, non-acceptance, impulse control. These are sub-skills within the difficulties in emotion regulation scale. We also have information on degree of empathy, and there are 3 sub-skills here. We have information on resilience, growth mindset, intelligence versus talent, as well as working alliance. So that's just to give you some context on where this data set is coming from. We're collecting data from students who are taking a course on trauma-informed approaches to working with kids and adolescents. And because it is an experiential course, they're tracking their own emotion regulation skills, their own ability to empathize with people, their own growth mindsets, types of cognitions as they learn about these principles. And so that's where the data set is coming from. 40 people have provided information on these subscales across 3 time points each. And this is the data. Okay. So what I like to do typically is I also like to kind of summarize the data set, figure out what's the mean standard deviation, descriptive statistics basically, as well as getting the names of the variables. So that's very easy. Names for PL. These are the variable names in there. And if you want the descriptive statistics, summary. Oops. Now it gives you the minimum value, the first quartile, median, mean, third quartile, maximum, and the number of missing values for each one. So let's do some transformation here. We know that the data set is currently in a percent level or wide form. We need to change it so it looks more like this in terms of the long form. We're going to use a package called panel R. So panel R package. We use this function to first of all look for this package in the CRAN mirrors, and there's multiple mirrors throughout the world. But what this is going to do is going to find this package, install it, and then after this, we need to actually load the library or load this package in order for us to actually use it. So we'll just kind of let it do this thing. It'll figure out what's the best CRAN mirror to pull this from and what are the specific functions it needs to upload. Again, if you're watching this video, feel free to skip ahead in case if this is taking too long. Okay. Let's next step is to load our package. To do that, it's very simple. The functions library, and you type in the name of the package. All right, so now that we have the data set loaded, now that we have the right package loaded, next thing is to use the function that is going to enable us to transform this data set from a wide format to a long format. So let's name this new data set master underscore PP. PP for person period. And that's an arrow pointing left. The function is long underscore panel because we're telling the computer to transform this from wide to long from the data set master underscore PL. And there are a couple of things that we want to know, which actually I probably should have mentioned this prior to doing this, this transformation, is that you would want to You can pull the data set here. You might need to change the names of the variables so that it's clear as to what aspects of the variables names are referring to the time labels and are they located at the beginning towards the end. So notice over here, for instance, we have this first variable representing strategy subscale for week 1. And notice how we have an underscore after the word strat. Underscore after the word strat followed by W followed by a number. And so you basically you need to decide if you would want a number or letter or something to indicate the time indicator. And you also need to know, or also need to decide if you want the time labels to be at the beginning or towards the end of the column names. In my case, I decided to make the end of the variable names to have the information on the time itself. So the prefix, for example, is underscore W. That means whenever the computer sees something underscore W, that tells it that that's the indicator for what week it is. And so we have underscore W1, underscore W2, underscore W3, and it repeats itself for the other variables too, underscore W1, underscore W2, and underscore W3. And so what the computer is going to do is that it is going to create a time variable that is going to capture that 1, 2, and 3 and transform that into a long data set. To make a little bit more sense as we start typing here in terms of the instructions. So I was saying the new data set is going to be named master underscore pp. On panel is the function. Master underscore pl is the original data set. And the prefix is going to be underscore w. Remember, this is what tells the computer as to what is the designation for the time, the time period. And the time periods are 1 to 3. So you can type in periods equals to 1, 2, and 3. And the label location, as in where underscore W is at, it's towards the end. And that's pretty much, if I got this right, with all the proper commas and periods and everything. Sometimes I mess this up. I need to go back and figure out what is it I messed up, and it can sometimes be frustrating, but once you do it multiple times, you usually catch on really quick. And it looks like I was able to do it pretty successfully. So let's say if you had 4 data points, it'll be C1, 2, and 3. If you had 2 data points, it'd be 1 and 2. But you really should have more than 2 data points if you're doing a longitudinal data analysis. And I would encourage you to look further into this book, Apply Longitudinal Analysis by Singer and Willett. Let me see if I can actually find the name of the book, or at least the picture of the book cover. Because the rest of my other videos on conducting multi-level modeling is going to be based on this book. This one. There you go. So the oldie goldie, and lots of people have used this book to help them do their respective analysis. So back to this. So notice now we have a new data set that we just created. It's called master underscore pp. It has 120 observations now, as opposed to 40 observations. And remember why? The reason why is because now we have 3 rows per person representing the 3 time points. So 40 times 3 for every 3 time points for each person is 120. I noticed that we have significantly less variables because we've collapsed from having 3 variables representing 3 time points. It's now 1 variable, and the rows are representing the time points. So let's take a closer look at this new data set that we just created. Yeah, so check this out. We have what the syntax panel R has done for us is that it created a new variable called wave 1, 2, and 3, representing weeks 1, 2, and 3. And now it is d_strat for that particular variable. And the 3 rows representing the 3 time points, so 2.00, 2.67, and 2.00 for person 1, and base 1, 2, and 3 should be the same as 2.00, 2.67, 2.00 in the original data set. If you wanted to export this data set, it's pretty easy. Just simply write a CSV, the file that you want to write. Call it whatever you want. So let's call it 627 scales -pp. CSV. Do that. That should give me this new data set. Oops, complete with my typing error. So let me fix that. There you go. That looks much better. Let me go ahead and delete this. So again, if you open this up, it should be similar to what we had just seen just now. Notice how we have wave 1, 2, and 3. And it is now a long data set. 120 rows as opposed to 40 rows initially in the original data set. So that's how you would go about taking a person level data set, making it into a person period data set, and check out the rest of my videos on how to basically start doing some multi-level analysis. So I hope this video was helpful. Let me know if you have questions, and I'll talk to you soon. Bye-bye.